Hello class, today we're going to learn how to solve equations. Our first equation is x plus 4 equals negative 12. One thing that you want to remember when you're solving equations is you have to isolate the variable, meaning getting the variable by itself. And we do that by what we call inverse operations. That means that we want to undo the operation that is at the current step. So as you can see, we're asking what number plus 4 equals negative 12, which means we need to undo addition. And the way that we undo addition is subtraction. So you want to make sure that whatever you do to the left side, you do to the right. So we're going to undo the addition, and instead of adding 4 to both sides, we want to subtract 4 from both sides. Now at this level in our math, now that we're in Algebra 2 Honors, you don't have to actually show that step. So you can go right to x equals whatever negative 12 minus 4 is negative 16. Now sometimes I have students that get confused on the negatives with integers, adding and subtracting integers. And I always like to give the example. Think of a negative as if you're owing someone money. So if you're already in the hole $12 and then you have to borrow or owe $4 more, then it would make sense that you're still in the hole because you haven't paid them anything. So basically, if you have a negative 12 and a negative 4, that means now you're in the hole $16. So that's one way to help you all with the adding and subtracting integers. And if you still need help, you can always let me know and I'll be more than willing to help you. But back to this example, we have now x equals negative 16. So now I want you to try this example. This will be example 2. 12b equals 18. Now, I want you to pause it, try it on your own, and then we will go over it together. Okay, if you did it correctly, you will see that since it's 12 times b, 12 times some number equals 18. To undo multiplication, you would divide both sides by 12. If you notice you're going to get a fraction, never fear. Just remember that all fractions, you want to make sure that they are reduced in their lowest terms. That means find a number that will divide into 18 and 12 evenly. Sometimes you may not pick the largest number at first, but at the end we should all get the same answer if you keep reducing. So I divided both by 6, and that's how I got 3/2. If you don't like fractions, you can always use decimals, which is 1.5. Make sure that you're trying these without a calculator, though. Okay, now we will try a little, try one that has more steps than just the one-step equation. Now, if you notice on the right side, we have 3 times the quantity y minus 3. Now, if you can remember back to Algebra 1, or if you can't, we're going to do what is called distributing. Very important. Make sure you distribute the 3 to both terms inside of your quantity. If not, you're going to get a different answer. So I use these little arrows to help me remember what I'm actually distributing or multiplying. You don't have to show that step, but it will be helpful. So I'm going to leave the left side like it is. I'm going to distribute the 3, meaning multiply the 3 by both terms inside of the parentheses. So you're going to get 3y minus 9. Now, at this step, we want to make sure that all the variables are on one side of your equation and all the other numbers are on the other. It does not matter which way you move your variables or your numbers, but make sure that you are getting one moving variables on one side, numbers on the other. Now, usually students like to make sure that the coefficient in front of your variable is positive, but it doesn't matter. So if that's your choice, you want to subtract 3y from both sides. And like I said, you don't have to show this step, but if you would like, you can do so. Very important. Make sure you keep that negative, because that's a common mistake that students make. They leave the negative off. And then the opposite of negative 27 is positive 27, so we're adding that to both sides. And then I'm going to bring down the 3y. And now you have negative 9 plus positive 27. That's like you owed $9, but you paid 27, which means you get money back. So 27 minus 9, that means that you would get 18. And there we have 3 times y equals 18, so we would divide by 3. And y would be 6. And you always want to make sure you get in the habit of plugging it back in to see if you get the same on both sides. You don't have to show that step. Okay, now you try. This is our got it. So we're going to see if you really get it. Our got it problem would be similar. Okay, I want you to pause it again. See if you can work it out by yourself, and then you can unpause and we can check our processes to see if they were the same. Okay, in this particular case, we had to distribute twice. Very important. Make sure you're really careful with those negatives and that you distribute, especially where you had to multiply negative 2 by positive 4, and that's negative 8. Now, if you notice, after you distribute, we had a 6x and a negative 6x. And that means that those two terms canceled out. And I know students probably may have gotten confused, like, oh no, my variables canceled. But if you look on the right side, we still have a variable of 11x. And very important. You don't have to add 3 to both sides. If you notice that negative 3 and negative 8 are on the same side, so all you have to do is combine those two terms to get negative 11. Once you get negative 11 equals 11x, you would divide by both sides. Now, this may look strange to some of you all because we have the variable now on the right side and we're used to it being on the left. It really doesn't matter. If you wanted to rewrite it, you could have had 11x equals negative 11. If it looks better that way, you would still divide by 11 and you would get either negative 1 equals x or x equals negative 1. Okay, we're going to try a word problem. Please don't get into the habit of skipping word problems, because you're going to see a lot of word problems not only in this class but standardized tests as well. So we have to get used to being able to look at a word problem and being able to interpret what's going on. I'm going to do problem 3 on page 28 in your book. I'll read it to you. It says, flower carpets incorporate hundreds of thousands of brightly colored flowers as well as grass, tree bark, and sometimes fountains to form intricate designs and motifs. The flower carpet shown here from Grand Place in Brussels, Belgium, has a perimeter of 200 meters. So, we know the perimeter is 200 meters. And make sure you write the units. What are the dimensions of the flower carpet? So if you notice on the picture, it's showing this carpet, and on the information, it gave us that this length was X and this was 3X. Okay, if you remember perimeter meaning the distance all the way around your rectangle. So that means you would add up all the sides. And if you remember on a rectangle, we know that the opposite sides are equal. So if this is X, that means this is also X. If this is 3X, this is also 3X. Okay? And we know that, or if you can recall, the perimeter of a rectangle is 2L plus 2W. Sometimes you may see 2X plus 2Y. It doesn't matter what you use. And so we have to look at what was given. We know we have our perimeter, which was 200. And if you look on here, our length, here's our length, which is 3X. So we're going to do 2 times 3X. And then our width, which is this one, we don't know, it's just X, so we got to do 2 times X. And it's helpful to put it in parentheses like this. So we're going to simplify the right side. So now this is 6X plus 2X. And then we can combine like terms. And we will get 8X. And you go back to your undoing your operations. So if you divide by 8, X would give you, and I'm just going to rewrite it this way, 25. You got to remember what did X represent. If you go back to your picture, you can look, and then we know that X was the width. So now we know that the width, I'm going to call it W, is 25. Don't forget your units, which was meters. Now, if the width is 25, that's this. How do I find the length? Well, we said the length was 3 times X, and X was 25. So that means our length would be 3 times 25, which is 75 meters. And make sure you go back to look and at what the question was asking. It said, what are the dimensions? So that's what we have. Our width is 25 meters. Our length is 75 meters. And we're done. Now, we're going to do a got it. Now, suppose we change the perimeter to 320 meters. Now, what would your dimensions be? And do you think your dimensions are going to be larger or smaller than what it was in our example 4? It's a good question. Okay, we're going to pause the video so you can have time to try it yourself. Okay, we were using the same dimensions from above, but now our perimeter was 320 meters. So pretty much everything was the same on the right side, where we got 8X from our previous example. So this time, instead of dividing by 200 by 8, we're doing 320 by 8, and that's how we got the 40 meters. And remember, X represented the width, and so to find the length, you have to do 3 times 40, because in our picture above, the length was 3X. And 3 times 40 is 120 meters. So your dimensions would be 40 meters by 120 meters. And see, that word problem wasn't so bad. Okay, now we're going to try another example. If you notice, I have variables on both sides. So what you want to do is combine like terms first on both sides. Now remember, you don't have to do undo operations because you're not moving one variable to the other side. Okay, so we're going to combine like terms on this side, and we should get 14x minus 7. And then over here we get oops. Let's redo this problem because I see we're going to try a different problem. Sorry about that. That one wasn't going to work out nicely. Now let's try. Look at this one. On the left side, we don't have to combine like terms. Only on this side. Okay. That we have to combine the variables. But on this side, we can combine our numbers. So we know that 11 minus 7 is 4. And then over here, 6x minus 3x is 3x. Now, I want you to look closely and see what happens here. I have 4 plus 3x on the left side and 3x plus 5 on the right. So you still want to combine or get the variables on one side and the numbers on the other. Doesn't matter which one you pick first. So if I subtract 3x from both sides, you're going to notice that the 3x's are going to cancel. And you're going to be left with 4 equals 5. Now, can 4 equal 5? Is that a true statement? Can 4 ever equal 5? No. So since this is never true, then this has what we call no solution. Because this is never true. Okay, let's try another one. We'll just call this B. Okay, same concept. You want to group those terms that are alike together. So on the left side, if you group those together, you're going to get 4x plus 5. But on the right side, when you group our like terms together, you get 5 plus 4x. And look closely, if you notice, those are exactly the same. And even if you got the variables on one side and the numbers on the other, you're going to notice that you're going to get 0 equals 0. Now we know this is a true statement, and since it's always true, we have what is called an identity. And when you think about identity, you think about yourself or the same or you, and 0 and equaling 0. That's going to always be true. Okay, so those are 2 examples. Now I want you to try I got it to see if you really get it, because I know when we're working this with the teacher, you're saying, oh, okay, I get it. So we're going to really see if you get it. So I want you to try it too on your own. Okay, here are 2 that I want you to try. And here again, I want you to pause it to make sure that you try it first, and then you can unpause it to check your answer. Okay, for the first example, when you combine like terms on both sides, we get 3x plus 6 equals 3x plus 4. Now, here's where we may differ on how we decide to move everything. So if you moved, or you subtracted 3x from both sides and got 0, and then subtracted 6 from both sides, you would have gotten negative 2. Now, if you decided to do it the other way, and you move the 4, you subtracted 4 from both sides, you would get 2 equals 0. In either case, you're going to get an untrue statement. And so you will have to use no solution. Okay, I want you to try that last one. I'll give you time. And then we'll check our answers. Okay. So in this last example, we had to distribute again on both sides. And make sure you're careful with the negatives. So you get 3x minus 12 when you distribute the 3. But on the right side, we're going to get 4x minus 12 when we distribute the 2. Then I showed you my grouping so you can see what I added together. I got 5x minus 12 on the left and 5x minus 12 on the right. And it doesn't matter which way you subtract. Just make sure you get the variables on one side and the numbers on the other. But you guys are going to start to see that even in this step right here, everything was exactly the same on both sides. So in that case, you're going to get 0 equals 0. And there's your identity again. All right, our last example of solving equations would be solving what we call a literal equation. Literal means that you have at least 2 different letters as variables in your equation. Now this is where you'll see a lot on standardized tests, and even in word problems. And this is very important because sometimes they're gonna ask you to solve for a particular variable. And just to give you an example, even with the area of a triangle, if you notice, we have 3 variables. You have A for area, base for B, and H is your height. And so sometimes if you notice it says A equals 1/2 BH, but sometimes they may ask you for B. And so you're going to need to know how to move everything so that you can solve for a particular variable. We're going to use another equation. This is another popular one. Does this look familiar? If not, this is the equation that relates temperatures in degrees Fahrenheit, which is your F, and degrees Celsius, which is C. Now they want you to find, or the question is, what is F in terms of C? That means basically solve for F, and when you get F by itself, your equation is going to have a C. So they want us to isolate this variable right here. So we're going to have to get it by itself. And you're going to have to use our method of undoing our operations, or using the inverse operation. So first thing you want to do, see this? That 5/9, we got to get rid of it. And when you undo 5/9, it's basically you're doing the reciprocal. So what is the reciprocal of 5/9? That would be 9/5. So that's what you're going to multiply both sides by. So what that's going to do is take care of this, because anytime you multiply a fraction by its reciprocal, you are going to always equal 1. And that way, on this side, 1 times anything is itself. So you don't need the parentheses anymore. I mean, it's okay to keep them. But on this side, you're going to have 9/5 C. And remember, we're trying to get that F by itself. So we have to undo this minus 32, which means you got to add 32 to both sides. And remember, you don't have to show that step. Okay, so you're going to get 9/5 C plus 32. Now, sometimes remember, some students like their variable to be on the left side. So if you want to rewrite it, that is perfectly fine. Now we have F in terms of C. And now, so if they ask you a question about if the temperature is in Celsius, find the Fahrenheit temperature. It's easy for you to do that. Okay? Now I want you to try a got it. Now I'm going to give you the equation for K equals C plus 273. This is the equation that relates kelvins, K, and degrees Celsius, C. And now they want you to find what is C in terms of K. So I'm going to give you time just to do that. Okay, that's how your equation should look, is to get C by itself. You want to subtract 273 from both sides. Okay, now that you have this equation, think about this question. Is the equation relating temperatures in kelvins and degrees Celsius always, sometimes, or never true? So that means that, is this equation relating when you're going from kelvins and degrees Celsius always or sometimes or never true? What do you think? Well, if you said always, you are correct. Well, that concludes our lesson on solving equations. Hopefully you took some good notes and you wrote down the questions that you may have. And if there are any examples that you did not understand, make sure you write specific questions so we can go over those tomorrow. Thank you for listening and thank you for participating, and have a good day.